Good afternoon to you viewers and subscribers, and welcome to another video. My name is Belly One Engineering. I just want to give a special shout out to those of you who have been watching my videos, to those of you who have subscribed. I'm really appreciative of that. And in my video presentation this afternoon, I'm going to be speaking to you about concrete mix as it relates to site. So without further ado, I'm going to be taking you through the presentation. So the first thing to note is that concrete design is a subject all by itself. It is a very comprehensive topic and a topic that is worthy to be known as a builder or a contractor or a site manager, or if you're a student going to college, you're going to be, especially if you're studying civil engineering or construction engineering or construction management, you're going to be getting some form of training when it comes to concrete mix. So the first thing we want to know about concrete is, what is concrete? And concrete is really a mixture of cement, water, fine aggregate, coarse aggregate, and air. And that sometimes when you want to improve the quality of your concrete mix, you can add admixture to your concrete mix to improve the quality. Secondly, there are several different grades of concrete. There are normal grade, which is primarily used for residential or commercial construction. There is the standard grade, which is used for bridge. We also have the high strength, which is also used for bridge. But at times, these different grades, they intertwine into each other. And at times you might find your normal mix coming to your bridge construction, as well as you might find your mix from your bridge construction that goes into your normal mix for your residential and your commercial. Now, for your normal grade, which we are going to be focusing on, since we are talking about building construction, there are several different grades or mixed proportion of your normal grade. Now you can see your normal grade, which is your M5, which is a 1 in 5 to 10 with a 5 megapascal or Newton millimeter or 75 or 725 pounds per square inch or psi. Now you have 7.5, which is a 1 to 4 to 8 proportion mix, which is a 7.5 megapascal or 1087 psi. Then you have the M10, which is 136, which is a 10 megapascal or Newton millimeter or 1,450 pounds per square inch. And then you have your M15, which is 124, which is 15 megapascal or 2150 pounds per square inch. And then you have the M20, which is 1 in 1.5 to 3, which is 20 megapascal or 2,900 pounds per square inch. But for this presentation, we are going to be speaking about primarily the M10 and the M15, which is 136 and 124 respectively, as it relates to building construction. So if you're going to use a 136 concrete mixed proportion for your site, you must always try to use multiples of your ratio. In other words, do not tell the laborer on site to just run on 5 barrels of coarse aggregate. Always try to go in multiples of your ratio. So this is a 136 concrete mix. So what you can do to get a proper mix proportion of a 136, you can just multiply your ratio here by 2. So you have 12 to 6 to 2. So you can instruct your laborer on site to run on 12 barrels of coarse aggregate as against 6 barrels of fine aggregate as against 2 parts of cement. And let me address something that I know that I can see that it is a regular mistake on site. When you have a mixed proportion of 136 or a mixed proportion of 124, this one here, it does not mean 1 bag of cement. And that is a regular mistake that I see on site. The one here does not mean 1 bag of cement to 2 barrel of sand to 4 barrel of crushed stone. Okay? If you're using a barrel as your measuring apparatus, it's supposed to be 1 barrel of cement as against 2 barrel of sand as against 4 barrel of coarse aggregate. Always remember that. The one here is really 1 barrel. And from my information, when I was a site manager, I know that it takes 2.5 bags of cement to fill a barrel. So if your measuring apparatus is a bucket, if you're going to use a bucket to proportion your mix, it is 1 bucket of cement as against 2 buckets of sand as against 4 buckets of coarse aggregates. Or if you, so whatever your measuring apparatus is or are, if you're using a teaspoon, it's supposed to be a teaspoon of cement as against 2 teaspoons of sand as against 4 teaspoons of coarse aggregate. And that is very, very critical. I know that material is expensive and you want to cut back on your cement, but I'm saying to you that is a bad practice. It's better you try to shave a bar or two of your coarse or your fine aggregate, but do not cut back on your cement, because your cement really is a binder, right? The cement really is a glue that holds, that binds the coarse aggregates and the fine aggregate together to come up with a structural concrete that can add to withstand the loads along with the reinforcing rebars. So always remember that if you're using 124 or 136, this one here is not 1 bag of cement. And that's a regular mistake that I see on site. It is not 1 bag of cement. It is whatever your measuring apparatus is or are that is supposed to be your cement. Another critical piece of information that I want to share with you as it relates to a concrete mix on site is that whenever you have decided on what mix proportion you're going to use, whether it be 124 or 136, right? You should factor your mix as I have indicated to you earlier. So in this case, we're going to factor our mix by 4. So we're going to have 4 times 4, which is 16, as against 4 times 2, which is 8, 4 times 1, which is 4. So you're going to have 4 parts of cement as against 8 parts of sand as against 16 parts of coarse aggregate. So the first thing to do is to instruct your laborer or whosoever you have mixing your concrete on site to run on your 8 barrels of sand. When you run on your 8 barrels of sand and you level it out, then you run on your 4 barrels of cement. So what we call sweeten back in the days, you mix up your sand and your cement together and then you level that out and then you run on your 16 barrels of coarse aggregate, right? But a regular practice that I've seen on site is that they run on the 8 barrels of sand first, right? and then they run on the 16 barrels of coarse aggregate secondly, and then they run on the 4 parts of cement on top of that aggregate. That is not the way all concrete mix is supposed to be done, right? You're supposed to mix up the sand and the cement first, you level it out, and then you run on your coarse aggregate, and then you part the middle, you put in the water. Because when you run on your sand and your coarse aggregate, and then you put on the cement on top of that sand and coarse aggregate, when you part that middle and the water start to run, it's going to take away the cement from out of your mix, and as a result, weaken your concrete mix. So you must always ensure to sweeten your concrete. You sweeten your sand and your cement first, and then you level that out, and then you run on your coarse aggregate, and then you pour on your water. That is the correct way how it's supposed to be done when you're doing manual mixing on your site. Another small bit of information I want to point out to you, that whenever you see on your plan a M5 or a M10 concrete mix, the M just stands for mix, and the number does stand for the strength. So in this case, this concrete would be 10 Pascal or Newton per millimeter square, right? So the M just stands for mix, and the 10, which is a number, does stand for the compressive strength of your concrete. In this part of my presentation, I'm going to be demonstrating to you how to calculate your batch mix for your concrete. So as you can see here now, this is a pad footing or a spread footing, as it is called in the United States, and the dimension for the column base of this spread footing is 1 meter high by 1 meter in width by 1 meter in length, which works out to be 1 meter cube. So in essence, we're going to be calculating 1 meter cube of concrete with a mixed proportion of 1:4. So the first step is to sum your ratio, and the sum of your ratio is going to be equivalent to 7. You total 1, 2, and 4, and that is equivalent to 7. The second step is to find your quantity of cement. So remember now, this is a 1:4 mix. The 1 is for the cement, the 2 is for the final aggregate, and the 4 is for the coarse aggregate. So the quantity of cement is going to be equal to 1/7 of 1 meter cube, which works out to be 0.14 meter cube. Now, the volume of cement, we need to come up with the volume of cement. So we know that cement weighs 1,440 kilograms per meter cube. So what we do now to get the volume of cement, we multiply that 0.14 meter cube by 1,440 kilograms per meter cube, and we end up with 202 kilograms. Now, we can do this two ways. We can both find the weight of the cement in kilograms, and we can find the weight of the cement in pounds. Now, we know that it is 2.2 pounds, which is equivalent to 1 kilogram. So in pounds, we already calculate 202 kilograms. So we times that by 2.2, and we get 444 pounds. Now we can calculate now our number of bags of cement. So 1 bag of cement, as I remember back in those days, I don't know if it has changed, but I know that a bag of cement weighs 94 pounds or 42 kilograms. So we're going to first find out the number of bags of cement in kilograms first. Then thereafter we have, so now we have number of bags of cement, which is 202 kilograms divided by 42 kilograms. and we get 4.8, and we round that up to 5 bags of cement. So we are now going to work out the cement, the bags of cement in pounds. So we know that bag of cement is 94 pounds. So we divide that 444, which we calculated here for pounds, by 94 pounds, and we ended up with 4.7 bags, which comes out to be 5 bags of cement. So to sum this up in terms of your cement, so we're going to need 5 bags of cement to mix this 1 meter cube of concrete for this spread footing. So we are going to move now over to our fine aggregate and our coarse aggregate, and we right. So we're going to work out our fine aggregate, which is the sand. So remember now it's a 1, 2, 4 mix, and the 2 is for the sand. So we have 2/7 of 1 meter cube, or 2/7 of 1 meter cube, which equals to 0.29 meter cube. So I know it's going to be difficult for some people to quantify meter cube. So I'm going to convert this 0.29 meter cube into cubic yards. So we know that 1 meter is equivalent to 3.28 feet, right? So therefore, 1 meter cube is going to equal to 3.28 to the cube root. So those of us, for the benefit of those who do not understand what cube root means, you just multiply that particular number by the power it is raised to. So here we're going to have 3.28 times 3.28 times 3.28, which is going to be equivalent to 39.29 feet cubed. So now we know that 1 yard, we know that 3 feet equal 1 yard. So if we're going to bring this to cubic yards, we need to bring it to cubic feet. So we divide that 10.3, which we get that 0.29 times 35.29, which is 10.223. We divide that by 27, and we ended up with 0.37 or 0.4 cubic yard. So for the quantity of sand, it is 0.29 meter cube or 0.4 cubic yards. So we do the same thing for our coarse aggregate, and remember the 4 is for the coarse aggregate, and we have 4/7 of 1 meter cubes, which work out to be 0.57 meter cube or 0.74 cubic yards. Now, we want to know how much water we're going to use to mix the sand, cement, and the coarse aggregate. So we know that the quantity of water, the water-cement ratio is within a range of 0.5 to 0.6. So we are going to take an average of 0.5 and 0.6, which works out to be 0.55, and we round that up to 0.6. So water-cement ratio for this mix is 0.6. So the water-cement ratio is, remember now, we have calculated the volume of concrete earlier, which works out to be 0.14 meter cube. So what we need to do now is to calculate the water. So the water over the cement is going to equal to 0.6. So therefore the water is going to be equal to 0.6 times your cement, and that works out to be 0.6 times 0.14 meter cube, as we have worked out previously, and that comes up now to be 84 kilograms. The reason why we times this 0.084 meter cube by 1,000 kilograms, remember now the density of water or the weight of water is 1,000 kilograms per meter cube, or 62.4 pounds per cubic feet. So when we times that volume, which is 0.084 meter cube times that 1,000, we are getting 84 kilograms of water. Or in pounds, which is going to work out to be 185 pounds. That 185 pounds is derived from that 84 kilograms times 2.2, which equates to 185 pounds. And remember now, it is 2.2 pounds, which is equivalent to 1 kilogram. So that is it for this video. If you do not understand the video, please just shoot me a comment in the comment section, or you can watch the video more than once to get a better understanding. But if that is not the case, just shoot me a video in the comment section. I will be very happy to answer your question. So remember to like the video, share the video, and subscribe. And I'm going to be seeing you in the next video, and I'm going to continue my concrete. So the next video, we're going to be looking at slum, air content, moisture contents, and air contents. So that's it. Take care for now. Goodbye.